Hello, good afternoon everyone. Today's physics topic, the fourth derivation of the same chapter. Okay, last and fourth derivation of the chapter. The derivation is like that. Torque on an electric dipole in a uniform electric field. From the heading, you already know what is a torque. What is a torque? Equal and opposite charges separated by a vector distance 2L, that is known as torque. Where is this torque? The torque is placed in a uniform electric field. So the torque is placed in a uniform electric field. We want to find out electric dipole. Okay. So consider a electric dipole. Dipole is the first term. We want to consider a electric dipole. So you can see here what is a dipole? Two equal and opposite charges. That means plus Q and minus Q. Where is minus Q? Placed at the point A and plus Q placed at the point B. Distance between them is 2L. 2L. Okay. This is a electric dipole. The charges are plus Q and minus Q. Distance between them is AB. What is that distance? 2L. Where it will be placed? This dipole is placed in a uniform electric field. You can to see here, this is uniform electric field. Uniform electric field means anywhere we should consider a point. Uniform electric field is same. So uniform electric field means full of the portion, electric field portions are same in each and every point. This portion may anywhere. I am considering the point A here, point B, point C. All the points contain electric field is uniform. That is called as uniform electric field. So this is a dipole. This dipole is placed in a uniform electric field. Next point is theta. Theta is an angle between dipole axis and the direction of electric field. You can to see here, this is our dipole A, B, and this line is dipole axis. You remember, you already studied dipole axis means the line joining of a different charges. That is a dipole axis. So where is theta? Theta, this is uniform electric field E. This is another line E, another line E, like that. So this is electric field and this is a dipole axis. The angle between dipole axis and electric field, that angle is called as theta. Okay, this is the arrangement. So from this arrangement, we want to find out torque. Okay, what is the arrangement? We want to consider an electric dipole placed in a uniform electric field, and theta is the angle between dipole axis and electric field. What is uniform electric field? Everywhere in this portion, electric field is same. Okay, then we have to move into the next top point. We want to find out torque. Okay, what is a torque? In the 10th physics portion, you should study torque equal to force into perpendicular distance. Yes, you are right. Torque means force into perpendicular distance. So we want to find out force first. Force acting on minus Q. Where is minus Q? Minus Q is placed at A. I am right? Minus Q is placed at A. So force acting on minus Q at A equal to QE. Okay. What is the direction of minus Q? Opposite direction of electric field D. You can to see electric field in this direction. But in the case of A, minus is there. That's the reason opposite to E. QE is opposite direction of E. Okay. Next point. Force acting on a plus Q. Where is the plus Q? Plus Q is placed at B. Where is B? B is the same direction of E. QE is the same direction of E at B. QE is the opposite direction of E at A. So B equal to plus QE. This is the same direction of E. In the normal condition, dipole is under the action of two equal and opposite parallel forces. So net force on the dipole is always 0. Normal dipole में net force 0 है क्योंकि dipole is equal and opposite parallel forces. That's the reason net force of the dipole is 0 in the normal dipole condition. But in this case, force exerted on the torque on the dipole because they act at different point. But in this case का speciality क्या है? Dipole is placed in a uniform electric field. That means one is same direction of E. QE is the same direction of E at point B, and QE is the opposite direction of A at the point minus Q. That's the reason the opposite directions are here. That means it have a turning effect. That turning effect is called as torque. So dipole, normal dipole, they do not have any force. But the dipole is placed in a uniform electric field. It have experienced a torque. What is the symbol of torque? Toe. What is a toe? Force into perpendicular distance. So toe equal to, what is the force here? We already know A is contained QE, B is also contained QE. That means force equal to QE and perpendicular distance. So you can to see in the diagram, this is 2L. I am just joining from B to downward and from A. So this 2L is an inclined force. All the inclined forces have two components. One is a cos component, other is a sine component. So from this arrangement, this is 2L is the inclined force. So 2L cos theta and 2L sine theta. So we have to consider perpendicular distance. Which one is perpendicular? This is horizontal. So this one is perpendicular. So we have to consider the perpendicular distance 2L sine theta. So torque equal to force into perpendicular distance. Force equal to QE. Perpendicular distance is 2L sine theta. So we should get the answer torque equal to QE into 2L sine theta. You know what is P? P is a dipole moment. What is the expression of dipole moment? 2LQ. So you can see here 2LQ. This 2LQ is replaced by P. What is the balance? E sine theta. So E sine theta is also here. So final answer torque equal to PE sine theta. Where is the sine theta is here? In the 11th physics you should study. Sine theta is denoted by cross product. So tau equal to P cross E. What is the unit of torque? Newton per meter. So we should get torque from the dipole placed in a uniform electric field. I hope you can understand this much. Please hear it 1 or 2 times and complete and try to understand.